Finally, let's demonstrate another way to incorporate risk into our models. So I'm going to copy this sheet, move or copy, we'll put it at the end. And right after total annual cash flows, we're going to add a couple of rows. So we'll have certainty, equivalent, coefficients, and then risk adjusted based off of that. So let's suppose today, period 0, we know for certain. Next period, there's a 95% chance of that happening. And based off these, let me drag that across. Okay, it's not going to work. Let's try one more. Maybe this will get it going. There we go. Okay. So in other words, kind of a probability that all these things will happen and or we'll get 95% of the cash flow. So to do the risk adjustment, that's just going to be equal to the total annual multiplied by the certainty equivalent. I'll drag that across. So now we'll modify our formulas appropriately. So now the NPV will instead be risk adjusted cash flows. So you can see let's make sure they have the right ones in here. Yeah. Okay. Let's see what's. One other modification we need to make, if you did the WACC, that would, with certainty equivalent, you don't use the WACC, you actually use the risk-free rate. My apologies. So risk-free rate, 4%. Because the risk is handled here, thus you don't need to count it twice, as we see. So B14 will now be B15. And we'll get 139,426.98. So still positive NPV. We would do this. We won't do PI nor the payback period or discount payback period. So we're going to use these. So now with respect to this, the IRR will be those. Whoops. And then the MIRR, and then B14, now B15 twice. So you can see that our IRR and MIR are much lower using this technique than if we used our original technique.